Hello learners, welcome back for the new video. In this video, we will design a rapid sand filter for the water treatment plant. You have a problem statement. Design a rapid sand filter for a flow of 4 mld. We have to design the rapid sand filter for a flow of 4 mld. So, the flow rate is 4 mld. Here we have to assume that the cleaning period of the rapid sand filter, cleaning period for designing or to calculate the actual quantity of flow, we need to assume the cleaning period. Let's assume is 30 minutes, and it means in one day we have to do the cleaning of the rapid sand filter. That means for 30 minutes the normal filtration of the rapid sand filter is stopped, and for 30 minutes we have to do the backwashing. That means the cleaning of the rapid sand filter. And during the backwashing or during the cleaning of the rapid sand filter, extra quantity of water is used. So that's why the actual amount of water that has to be treated during the process of rapid sand filter is more by 4%. So the actual quantity of flow will be Q is equal to, so let's assume 4% of water is used during cleaning. So I will write here, assume 4% of water is used in cleaning. This 4% of water contains lots of suspended impurity which were clogged in the rapid sand filter during the normal filtration. That's why this 4% of water is recirculated to the rapid sand filter or recirculated to the sedimentation tank. That's why the actual quantity of water will be more. So it will be 4% more. That means 1.04 times the actual flow. That is 1.04 into 4 mld, 4 into 10 raised to 6 liter per day. So let's convert it into meter cube per hour. 1.06 into 4 into 10 raised to 3, and 10 raised to 3 liter means meter cube per day. 1 day is equal to 24 hours. So after solving this, you will get the quantity of flow in meter cube per hour, and it will be 177 meter cube per hour. Okay, wait, here we have to here in one day, actually in one day we are doing the normal filtration, or we are doing the filtration of water for only 23.5 hours, because 30 minutes, that means half hour is for cleaning. That's why here we have to take 23.5 instead of 24, because half hour is used for the cleaning of the rapid sand filter. That's why in one day the total operating hours will be, or the total working hours will be 23.5. That's why here we have to divide the flow rate by 23.5 instead of 24. And after solving this, you will get the flow rate in meter cube per hour as 177. So let's start the actual design of the rapid sand filter. So assume rate of filtration. Rate of filtration is, let's assume it to 5 meter cube per meter square per hour, or it is considered as meter per hour. Okay, rate of filtration is 5 meter cube per meter square per hour. We know that the formula for rate of filtration is Q upon area. So area is equal to Q upon rate of filtration. Q is 177 meter cube per hour, and the area is 5 meter cube per meter square per hour. So after calculating this, you will get area as 35.46 meter square. This is the area of rapid sand filter, or this is the surface area of the rapid sand filter. That means the plan area. Okay, now we have to in this rapid sand filter we have to calculate the number of units. That means this area is divided into n number of filtration unit. That number of filtration unit we have to find. So number of unit can be calculated by using the formula, empirical formula 1.22 into Q. Here the formula is 1.22 under root of Q. Here the value of Q is in MLD, and we have the value of Q as 4 MLD. So 4, that means 2, it will be 2.44 numbers. Okay, so I will take it as number of units to 2. You can also take 3. There is no problem in taking 3, or there is no problem in taking 2. Okay, so this is the number of units. So after calculating the number of units, we can calculate the area of 1 unit, area required for the 1 unit. So area of 1 unit will be total area 35.46 divided by number of units 2. That means the area of 1 unit will be 17.73 meter square. Round up it to 18 meter square. Now generally the rapid sand filter are of rectangular shape, so let's assume it is rectangular, and L by B ratio of the rapid sand filter is 1.5. let's take L by B ratio 1.5. L is equal to 1.5 times B. So we know that area is equal to length into breadth. Length is 1.5 times B into B, that is 1.5 B square. Area is equal to 1.5 B square. Then the area of one filter unit is 18 meter square is equal to 1.5 times B square. So after calculating this, we will get the value of breadth as 3.46 meter, actually round up it to 3.5 meter. Therefore length will be twice the breadth. That means length will be 1.5 times the breadth. That means 1.5 into 3.5 is equal to 5.5 meter. The length and breadth of we have calculated the length and breadth of the filter unit. Here we don't need to assume the depth, because the depth is depend upon the media media depth. Suppose if the depth of sand is the depth of sand should be in between 0.45 to 0.9 or 0.6 to 0.9, then depth of gravel. So after assuming the depth of sand, depth of gravel, water head, the total depth of the total depth of the rapid sand filter is calculated. So in this design we don't need to find that depth. Okay. So because that depth does not depend upon the flow rate, that's why we will not find that depth. Okay. Now this is the here the design of the half design of the rapid sand filter is complete. Now we have to design the under drainage system of the rapid sand filter. Design of under drainage system, because after filtration the water is collected at the basin of the rapid sand filter, and then that water is collected in the under drainage system. That water is collected through the under drainage system, and then it is transported to the further treatment unit. That is it may be water softening unit or a disinfection unit. So let's design the under drainage system. Under drainage system include perforations area, means in under drainage system there are pipes, there are n number of pipes are laid, and on the surface of the pipes there are small holes, and that holes are called as perforation. And we have to, in the design of under drainage system, we have to find the area of that perforations. So the perforations area, then laterals. Okay, so I will draw the, to explain the what is laterals, what is manifold, I will draw the plan of the rapid sand filter. Suppose this is the plan of the rapid sand filter and this is the basin. In that basin, suppose this is the manifold and these are the laterals on both sides. Okay, laterals have perforations. Laterals have the water which is at the water after the filtration, the water will goes into the laterals to this perforation, and these laterals will transport the water from laterals to the manifold. This is the manifold, the central pipe is manifold, and the smaller pipes are laterals, which is ultimately connected to the manifold. So then laterals, then manifold. Now here we have to assume initially we have to assume the perforations area, then we have to find, then we can find the laterals area, number of laterals, then manifold area, manifold diameter. Okay, and after finding that, then again we have to find the perforation area. First initially let's assume the total area of perforation is equal to, let's assume it as 0.2% of cross sectional area. 0.2 times cross sectional area is length is 5.5 meter by breadth is 3.5 meter. So after calculating this, you will get the area of perforations as 0.039 meters here. Now we have to assume the laterals area of laterals. So assume the area of lateral. Area of lateral, let's assume it as twice the area of perforation. Twice the area of perforation. So 2 into 0.039, that means 0.078. That is the area of laterals is 0.078 meters square, and the area of a manifold will be twice. So assume the area of manifold is twice the area of lateral. Why it is taken as twice? Because here the perforations water will go to the lateral, and the water which is present in the lateral will go to the manifold. That's why the area of laterals will be twice the area of perforation, and area of manifold is twice the area of lateral. So twice the area of lateral is 0.078, get 0.156 meters square. The area of manifold is 0.156 meters square. So this is the cross sectional area of the manifold. So the area generally they are of pipes are of circular type. So area will be equal to pi by 4 d square, 0.156 upon pi by 4 into d square. So you will get the diameter of manifold as diameter of manifold as 0.45 meter. 0.45 meter. Diameter of manifold is 0.45 meter. Hence, provide a manifold of diameter 0.45 meter along the length of the filter unit. Suppose this is the length, and the value of length is 5.5, and this is the breadth, and value of breadth is 3.5 meter. So provide the manifold of diameter 0.45 meter along the length. Now Assume here the laterals are placed parallel to the width of the rapid sand filter, and they are placed at some distance from each other. So let's assume the spacing between each lateral. So assume spacing between each lateral as, so let's assume 15 centimeter. Maximum you can assume spacing 30 centimeter. I have assumed 15 centimeter. So the number of laterals along the length will be so total length, number of laterals can be calculated by total length upon spacing, total length of the rapid sand filter divided by spacing. Total length is 5.5 meter divided by spacing 0.15 meter. We will get the number of lateral as 36.6. Let's round up it to 37 meter. So here the laterals are equally placed, or the laterals are divided by the manifolds. That means 37 laterals are placed to the left side of the manifold, and 37 laterals are placed to the right side of the manifold. So the total number of laterals will be is equal to 37 into 2, that means 74 laterals. Okay, this is the lateral. Now we have to find the we have calculated the number of laterals which is present in the rapid sand filter. Now we have to find the length of the lateral. We know that the length of lateral should be equal to the width, will be equal to the width minus the diameter of the manifold. So, and we have to divide it by 2, because it is half lateral, or one lateral is placed half to the width of the rapid sand filter unit. So, or take while calculating the length of the laterals, you can take the half width minus the half diameter of the manifolds. So you can find in any way the length of the lateral. So the length of lateral equal to width, total width minus diameter of manifold divided by 2, because the laterals are placed half to the half left side of the manifold and half right side of the manifold. So width is 3.5 minus 0.3.5, diameter of manifold is 0.45 meter divided by 2. So you will get the length of lateral as 1.525 meter. This is the length of the lateral. Now assume the diameter of perforations. That means suppose this is a pipe and there are holes are present on the laterals, or this is called as perforation. So assume the diameter of these perforations. Assume the diameter of these perforations as, let's take it 12 mm is equal to 0.012 meter. So the area of one perforation will be pi by 4 into 0.012 square. So the area of perforation will be 9.42 into 10 raised to minus 6 meter square, the area of one perforation. From this we have the total area of perforation, we have the area of one perforation, so total number of perforations will be the total area of perforation upon area of one perforation. The total area of perforation is 0.039 meter square, 0.039 meter square divided by area of one perforation is 9.42 into 10 raised to minus 6 meter square. After calculating these, the total number of perforation will be 4140 numbers. The total number of perforation is 4140. Now calculate the number of perforations per lateral. So number of perforations per lateral, that means how many number of perforations will be placed in one lateral. Okay, so this will be 4140. Total number of perforations are 4140 and total number divided by total number of laterals are 74. Will get it as 11.89. That means the total number of perforations are 111.89. Sorry, after dividing 4140 by 74, we will get the number of perforations per lateral as 55.9. that means 56. In one lateral there are 56 number of perforations. So we know that the total number of perforations in one lateral is 56, and we know that the area of one perforation, so the area of perforation in each lateral will be area of perforation in each lateral is 56 number of laterals, and area of one lateral is area of one perforation is 9.42 into 10 raised to minus 6. So you will get the area of perforation in each lateral as 6.33 into 10 raised to minus 3. 6.33 into 10 raised to minus 3, the total number of area of perforation in each lateral. Now we have to calculate the area of each lateral. Okay, now we have assumed the area of each lateral by assuming the area of perforation as 2%. Now we have the actual area of perforation. From this actual area of perforation, we can calculate the area of lateral as, this will be the twice as we have assumed previously. Same you have to assume the area of lateral will be equal to the twice the area of perforation. So area of lateral is equal to twice the area of perforation. So 2 into 6.33 into 10 raised to minus 3. So this will be equal to 12.66 into 10 raised to minus 3 meter square. This is the area of lateral. From this area we can find the diameter of lateral. Area is equal to pi by 4 into d square. 12.66 into 10 raised to minus 3 is equal to pi by 4 into d square. So the diameter of lateral will be 0.0 127 meter. The diameter of lateral is 0.12 centimeter. This is the design of rapid sand filter and under drainage system. In under drainage system, we have to find the area of total area of perforation, number of perforations, then area of lateral, then diameter of lateral, then area of manifold, and the diameter of manifold. These are the appurtenances, or these are the parameters that we have to design for the designing the under drainage system of rapid sand filter. Thank you.